We're at 1 minute past 3, so everybody should be on now. So I think we'll get cracking. I'm just going to start off with a quick poll whilst I do the formalities. So hello and good afternoon, everyone. My name's Sam. I'm the marketing manager at Open Reality, and I'll be hosting the webinar today. You've already had a quick glimpse of our speakers today, but before I introduce them formally, I'd just like to remind you that you're going to be in listen-only mode throughout the session. So if you do have a question, please use the questions box for that. We're also recording the session today, so you will also get a recording following the webinar if you want to watch anything back. So our first presenter today is Carter. He's joining us all the way from Texas in the USA, as he just mentioned. He's the CEO and owner of Acceltex. He's got over 20 years of experience in the Wi-Fi industry, and has also previously been a co-owner of TerraWave Solutions and GigaWave Technologies, for anybody that's familiar with those companies. So howdy, Carter.
Howdy. Appreciate it, Sam. Thanks for letting me on, and thanks everybody. Probably good afternoon for most of y'all. I appreciate it. Yeah, we're excited about our partnership with Open Reality. We appreciate you guys having us on the phone. And as Sam said, I've been in the industry for a while. I am from Texas. I'll try to talk. You know, most people from the southern United States are supposed to talk slow, but I talk kind of fast. So if I start talking too fast, matter, Sam, tell me to slow down. Or if y'all can't understand me, or if I say a word that's a Texas word, but I'll try to not do that. And I've got to the right of me in his black shirt, Mr. Matt Wenham. Matt, I'll let you introduce yourself real quick.
Yeah, hello everybody. So I look after sales for Europe. Again, as Carter said, thanks to Sam and Open Reality for the partnership. Yeah, looking forward to working with the team more closely. And yeah, let's jump into this session today about antennas.
So, yeah. And what did the poll say, Sam? Just more curious.
Yeah, so I just wanted to say, if anybody recognises Matt, that's because previously he worked for Ekahau as head of sales in the UK and Ireland, and I know that a lot of the audience today will be Ekahau customers, so you may already have met Matt. Obviously, from an Open Reality perspective, it's great to be working with him again. And so, yeah, we just had a quick poll here just to sort of see where people were at for and why they joined the webinar today. So a lot of the audience here seem to be sort of resource gathering, about 3/4 of the audience here just for sort of learning. About roughly 12% want to improve an existing network, and obviously are thinking external antennas might help them do that, and another 12% here looking into external antennas for a future project that they've got coming up.
Okay, well, great. Well, then good. Yeah, so we'll focus, we're going to try to keep this around 30 minutes just out of respect for your time. As Sam said, Matt has some Ekahau experience. He's going to do a little Ekahau demo at the end. Seeing as he worked at Ekahau, I hope he doesn't mess it up, but hopefully he'll do a good job. So anyway, let's get this thing. Okay. And just to confirm that it did toggle to the second slide. So a little bit about who we are. I'm not going to spend a ton of time, but if y'all don't know who we are, if you haven't heard of us, we actually, again, I've been in the industry for a while, but our real focus and what we really, our sweet spot, I guess, is designing, engineering, and manufacturing products that attach or complement your wireless access points, whether it's Cisco, Mist, Cisco Meraki, Aruba, Extreme, whatever. We build those solutions that kind of attach around it. We've been working in Europe now for a couple of years, but really the last year with bringing Matt on and bringing on great partners like Open Reality, we really have seen our business in Europe. I think it's going to grow, and Matt will probably attest this, probably 10x this year, which is really, really exciting because of just a lot of just focus and excitement, and a lot about the industry. I mean, you guys are obviously care about the Wi-Fi space, and y'all know some of the stuff that's happening not only today, but it's coming out. A lot of people are Wi-Fi is no longer a nice to have. You have to have it, so everybody has it. So it's not a matter of having it, it's whether or not you're going to upgrade to the next version. A lot of what we do too is customization. Again, Matt's your guy. Obviously, Open Reality is your starting point, but if there's any kind of customization around products, even around antennas, and sometimes customization can be around, I just wanted it to be a different color. I mean, we're really good at doing that. So just, let us know where we can help. Some of the products, I don't want to spend a lot of time. We're going to focus on antennas now, but again, Antennas are our biggest line by far, mounts, enclosures. I will talk only briefly about power solutions only because it may be our fastest growing business. And when I say power solutions, I'm talking about remote power as well as like solar. And a lot of it's being driven by what's happening with COVID. So we're getting pulled into a lot of education opportunities. And I'm sure it's the same over in Europe, where either they need a quick network somewhere and they just don't have power, or it's an area like a parking lot where they maybe want more permanent, but they still don't have power. We're setting up a lot of solar solutions where, it'll provide like a little hotspot, and a lot of it's for kids to come and maybe sit in the parking lot for an hour. Maybe they're in an area where they don't have really good network connectivity, or maybe it's an issue where they don't have the budget, they can't afford it or whatever. They're trying to provide it in these areas to provide access to everybody, because obviously we're still doing a lot of remote learning over here. So it's been kind of interesting to see how this whole COVID thing has affected the power solutions and really our business. And you guys in the technology space probably see it. It's actually, it's a very unfortunate thing, is actually highlighted how important it is to have technology like Wi-Fi and have good technology when to be able to connect and do things. So main goal today is external antennas. So obviously you have two different styles of way the radios are. You can have integrated antennas, which there's nothing wrong with that, or you can have, like in this example, where you have external antennas. If you have the application that allows you to put the access point in an area where you don't have to use external antennas, that's fine. I mean, all these radio manufacturers do a really nice job of building in good internal antennas that provide great coverage. If you're normally trying to do more of an omnidirectional coverage, because most of those access points are going to have omni-style antennas to cover areas. And if you're in a position where maybe the access point, you don't really care, where it's mounted or even care what it looks like. Internal antennas are great. But a lot of times, and we're seeing it more and more, where external antennas are necessary. Example would be if you're trying to achieve coverage in hard to reach places. An example would be, maybe like a manufacturing area where you're trying to cover in a certain area, but there's a lot of manufacturing machines that are in the way. You may have to use directional antennas to get coverage in those hard to reach places. Focused area coverage, another one. You might be trying to, we've seen people cover elevators. We've seen people cover stairwells. I mean, right now, as you well know, people want coverage, wireless coverage everywhere, period. In the old days, they were acceptable with having certain areas that didn't have coverage. Those days are gone. So having to cover areas that are, you needing to focus your coverage is very important. And that's where directional antennas can be very, very important. Aesthetics. We're finding people caring about what the network looks like almost in every vertical. It used to just be in maybe retail where people wanted it to look pretty, but now it's in schools. Obviously always in stadium type applications, whether it's a big soccer stadium or a hockey stadium or basketball or whatever. They want to make sure the installation is great coverage, but they don't want to see anything. It's always, we don't want to see it. So using external antennas, a lot of times you can use much smaller form factor, like this little antenna here. Great antenna, pretty small, much, much smaller than the access point. I can hide it. I can sometimes put a skin over it to cover it and make it blend in. But you can use external antennas a lot if you're trying to get an area to have aesthetics. High ceilings, another big reason for external antennas. You could have these big auditoriums or big distribution centers that are 20 plus meters high. Well, if you're going to use an antenna with integrated, or an access point with integrated antennas, you're not going to get the coverage down, 20 meters. A lot of times you may have to use a directional antenna beaming down. And so that's where these external antennas come very handy. Cell sizes, sometimes you want to limit it. When I first started in the industry, it was all data collection, like scanning, barcoding. All we cared about was big coverage because we were sending very small packets of data and we were just scanning. Those days are over. Now it's all high density. It's how do we have small cells where we can put a bunch of people in one area and not, have an issue with the next antenna, because again, Wi-Fi is half duplex and we want to make sure we're not having interference. A lot of times we have to limit the cell sizes. We have a deployment we've done in the States for years now. I've been working with these guys forever. It's an education for K through 12. And it's where you want to limit the cell sizes, by putting an access point per classroom. So when you're trying to do an access point per classroom, that's very tough. So how do you do it? You do it with these focused external antennas. Another one's deploying outdoors. A lot of times people want to deploy like in parking lots or deploy in, areas where like trucks are coming in, like for a distribution center. Putting your access point, most of these access points are not rated for outdoors. You can put them in an enclosure, and that's used and done a lot. But a lot of times we tell people put the antenna on the outside of the building, as an example, and put the access point inside. So you might have a situation where you can get great coverage, and your access point can be right inside. It'll keep the access point a lot safer. And the last one, and I always tease all the access point manufacturers that, if you're in an area where you're trying to build out maybe like a big warehouse, a lot of times with smart antenna selection and using the right antennas, you can maximize your capabilities, your access points. Another way to say it is you might be able to get away with using less access points. So maybe instead of 100 access points with the right antennas, you're using 80 as an example. I know the radio guys don't want to hear that, but it's just a smarter way to do the network. So anyway, so that's kind of why we use external antennas. So types of antennas, there's all different types of antennas, and you'll hear different names. But when you boil it down, just to keep it simple, there's really two different types of coverage of the antennas. One is either omnidirectional or directional. And I'll talk about both of those. Obviously, the ones on the left are omni, and the ones on the right are directional. So when you're looking at a directional antenna, I'll show you one here. This is an example of a very popular directional antenna. At its basic, when you think of an omnidirectional antenna, think about it starting where it's you're starting with a balloon, and that's your omni coverage. So let's say that would be a 0 dBi antenna would be a balloon. Now, what you do is, if you want to get different coverage on this omnidirectional pattern, you need to manipulate the antenna by adjusting and working with the gain. So think about, again, a balloon being 0 dBi, and let's say you want a 4 dBi antenna. Well, the way you do it is you basically think of squashing the balloon, and what that does is pushes out the vertical pattern, as you can see on the screen there in the bottom right. So as you go up in gain, what you get is a much flatter, bigger pattern from a vertical perspective, but what you lose is the horizontal side, or the up and down, which means you may have great coverage left to right, but underneath the antenna, you may have no coverage. So that's why people always ask, why do you have so many different antennas? Well, it depends. A very high gain omni is pretty common in like point to multi-point bridging applications. A very high gain omni is not that common in building. You're going to use lower gains, 4 to 6 dBi, maybe something like this for in building, because you need to have more of a circular type coverage. And one thing that you also have to remember too, when you're talking about antenna theory in general, we're dealing with a fixed amount of power that this radio can put out. A lot of it's based because it's an unlicensed technology, and we're basically have to be friendly neighbors, if you will, working with each other. Each governing body is a little different, whether or not you're in the U.S. or in Europe or in Japan or whatever theater you're in. But you only have so much power. So how do you get different coverage, and it's not necessarily better coverage, it's different coverage. You do it by manipulating the gain of the antenna and adjusting the horizontal and vertical beam width. So just think about, if it's a high gain antenna, think about like a pancake almost. It's squashed. And a lower gain, 0 dBi being a balloon, and anything in between is basically squashing this balloon up and down. So that's the omnidirectional. Directional, a little bit different. So this is a very popular directional antenna. You can see it from the side. Think about, I don't know, here in the States, a lot of our police officers carry what's called a mag light. And those are those big, long black lights that you can adjust them by dialing the head and make them go either real focused or kind of beam them back. Directional antennas work the same way. So a very low gain directional antenna, think of the mag light completely open and broadcasting very broad. So let's say you walk into a room, a decent sized room, and you just want to have light. You may walk in with it at the setting that's the broadest. You're able to see the whole room. You can't see anywhere far away very well, but you can see the whole room. But let's say you hear a noise in the corner. You can take that mag light and dial it down to where it's real focused, like in this bottom picture in the left. And from that, you can, find something like, say, what was that noise? Directional antennas are the same thing. Again, we're starting with an access point that has a maximum amount of power that it can output just by regulation. How do we make it cover longer distances, cover big warehouses, cover big places? You do it by adjusting the gain and basically dialing it in like a mag light. So you measure it all in horizontal and vertical beam widths, but as your gain goes up, you're usually tightening the different beam widths. And there's different ways. Sometimes you'll tighten just one of them. We have, an antenna that we have, one of the horizontals real tight, like 15 degrees, but the vertical is 120, and it's for this specific application. So just being able to dial it in is very important. But so think about when you're looking at directional, it's for very focused coverage, and it's for coverage coming out. Really, you don't want a lot of coverage out back. It's for a very focused directional versus the Omni, which is more circular pattern for whatever that, application is. So that's really at a high level your two directional style or your two types of antennas. How to read a radiation pattern, I'm not going to spend a ton of time, but it is important. People use this a lot. A lot of times people are like, okay, I'm going to go do a survey at this place. What antenna should I start with? Well, a lot of times we'll look at these patterns to get an idea of where to start. And then Matt will talk about the Ekahau predictive tool. There's other guys out there that have predictive tools, and then you can follow it up by doing a physical site survey. But if you look at the one on the left, it's an omnidirectional antenna, and you're trying to show how this thing covers you basically in 360 degrees on a piece of paper. That's kind of hard because it's a piece of paper. So if you look at the way this is, if you're looking at the piece of paper like this, the way this is measured is the red is basically as if the paper was almost like this. So it's showing that it's 360 degrees. Now, as you squash it and manipulate it with the gain, that's how the pattern starts going out left to right. And that blue line will start getting flatter and start squashing out as the gain goes up. I can just tell this is a lower gain antenna because the blue's fairly circular. Maybe it's a 2 dBi or something like that. So that's kind of how you read it is the circular, and then how you're manipulating it by squashing it down again like a pancake. Directional is a little different. When you're looking at it, again, I bring up the piece of paper because that's what you're going to have. It's actually putting it like this. So the pattern comes out this way, but if you're reading this diagram, it's actually looking like that. So if you look at the red and the purple, that's going to be your horizontal and your vertical beam widths. And again, it's just going to be measured in degrees. It's going to be 50 degrees by 60 degrees as an example. You just need to look at it to decide, okay, is that going to meet theoretically on paper what I want to do? I mean, again, these are just to know kind of at a high level what these antennas do. And then you obviously go to the next level with a lot of these cool tools we have. So that's kind of just a high level. This one right here, and before I do this one, this is very, very important because I would say this is where I've had most, in 22 years in this industry, most of the issues where people have said, I love the product, but I've got problems. It's because of connectors and number of leads. And I know, Sam, you were going to do a quick polling question.
Yeah, that's right. Just interested to see what people are using as for their primary access point vendor.
Yeah,
and then we can talk a bit more about
who's the biggest. Yeah. While he's doing that poll, I'll talk at a high level. So the thing that's common about connectors with access points is nothing's common. And that is the truth. If you look at Cisco, which love Cisco, they use RPTNC mostly. If it's Cisco Meraki, they sometimes have install. Even Cisco has some install for their outdoor products. So you got to be real careful when you're dealing with these antennas and even jumper cables and all that. It's making sure the connectors match. Mist, which great partner of ours, they use RPSMA. Aruba uses a lot of RPSMA. It just depends, on the radio manufacturer. The first question we always ask is when somebody calls us about an antenna, really anything, is what radio are you using? Because from that we can determine a lot of things. And I don't know, tell me when you get the poll results, Sam, because
yeah,
I'll just keep talking until you do.
So just under half using Cisco. We've got about 15% Meraki, Aruba, and then about 28% other. So
okay,
yeah,
perfect. So that's good. Yeah, so that means that you guys are going to get in a situation where you're really going to know that radio. Because another thing that's crazy, it's not just the connector; it can be the number of leads too. I mean, and even within the same manufacturer, they have 3 leads, 4 leads, 6 leads, 8 leads. You're seeing some, sounds like a lot of you guys use Cisco. Some of Cisco's new Catalyst stuff actually has a Dart connector, which is a specialty connector. Nothing wrong with it. It's a cool connector, but it's for, allows you to do 4 leads, 8 leads. But you got to know what that is before. Otherwise, it's not the end of the world if we shipped you an antenna and didn't fit. It's just it's a hassle. If we can find out up front what it is, it just makes life easier. Because again, people will come in and they'll say, "Hey, I got the Cisco network, but this antenna is not connecting." Well, it's because the connector is different. And if you haven't seen it before, and maybe some of you on the, like you look at this, that's a Cisco, very common Cisco RPTNC. Whereas like if it's missed, it's going to be this RPSMA, and you can see much smaller and just a different style. Both great connectors. It's just different, and just making sure you know. So the last thing, and then I'm going to talk real quickly about some use cases and turn it over to Matt just to keep respectful of the time, is this whole theory or this whole effective isotropic radiated power and why you should care. Because Wi-Fi is unlicensed and it's it's a half duplex. We have to be what we call friendly neighbors. So, and you may be put in a network and you may be close to somebody else that has a Wi-Fi network. So it's very important that you know what the EIRP limits are in your theater. Because the way it normally works is it's your responsibility as the installer, if you're installing it, to know what that is. And it varies. It's different in Europe, in the US. I know there's stuff in Japan, different parts of the world. But basically what it is it's adding the power coming out of the radio, the cable loss, you subtract that, and then you add the gain of the antenna. As long as that math comes up less than what the EIRP is in your theater, you're going to be probably okay. So it's making sure you know that. So, and why it's important is with some of these connectors, you can buy antennas that might fit on the access point from anybody for that matter. And you may be way out of guidelines on what the EIRP is for your theater, even though it may work, but you don't want to get in trouble with the governing body. So just know what it is so that you're staying within it. And you may like an antenna that's perfect, but you may have to do some things to get yourself below the EIRP, maybe add cable loss. You may turn down the power. You can do things that get you below that where you can document, hey, I'm within guidelines. I just love this antenna because it has a certain pattern. It may be higher gain, and that may be why I like the pattern, but I got to make sure that I'm keeping within that. So very important that you always be mindful of that with our technology.
Carter, just before you move on, we've got a good question actually from Gary saying, how do you factor in loss on an antenna cable? How far can you put the access point from the antenna?
So it's going to be different between 2, 4, and 5 gig, the loss. So the way coaxial cable works, they for every, let's say, foot, you're going to have some kind of dBi or fraction of a dBi loss per that additional cable. And it can add up very quickly. And that's why people always say, why do you have, 100 series cable, 195, 240, 400, 600? Like, for example, this is a real small, almost even less than 100 series cable. You see how little it is. Whereas this is a 195. The cable size you choose is going to be is a good direction proportional to the loss. So the question is, how far can you go? It's going to depend on what cable you start with. And what cable you start with is a lot of factors, because it may be that you have to be able to bend around a tight corner. If you go to a much thicker cable, which can be, maybe it's the size of your, your finger or something, it may have a lower loss coefficient, but you may not be able to go very far, or you may not be able to bend it around a corner that you have to go. So the question of how far you almost need to do the math. If it's, if you want to go, 20, let's say you want to go 5 meters, you may say, okay, I want to go 5 meters. If I know that and I know what radio you're using, I can tell you what the loss is going to be at 2, 4, and 5, and then you can do the math and see if that still works for you from a gain, from an EIRP and from a propagation perspective. At the end of the day, it's all about how does it propagate. The cool thing is it's mathematical. We can do some good mathematics, and we can tell you even before you test it if it's going to work. In general, we use extension cables. There's nothing wrong with it. I wouldn't go too far, though. I mean, you start getting, we use 600 series, which is pretty big, and you get much above, about 40, 50 meters, boy, the loss really, really gets to you. You don't want to go too far unless you just absolutely have to.
Okay, fantastic. Well, Gary, if you want any more information on that, then you can just reach out to us and we can.
Yeah, just reach out to Matt, reach out to you guys at Open Reality, and we'll do the math for you. It's 2, 4, and 5 gig. That's where it's, everything's dual band now. It's not the same math between the two. One's going to have different loss based on just being a different frequency.
Great.
So a little bit on which, I'm just quickly going to blast through these verticals, and then I'm going to turn it over to Matt. But which antenna for what application? People again always ask, why is there so many different antennas? It's because there's so many different ways in the world that we deploy wireless. It's a much different installation if I'm doing a school versus a big distribution center or a big manufacturing facility, versus, a big soccer stadium. All different. So it just depends. So depending on where you start. So in general, in my head, if you're thinking, okay, if I've got a big open area or maybe a big parking lot or an area that I just kind of need a nice big round type coverage, Omni antenna is really a great place to start. If you just want to have maybe a broader coverage, or maybe you're putting it outside. If you need more focus coverage, which a lot of the external antennas we sell, I'd say more, I wouldn't say more number of different customers use a lot of directional antennas because they're trying to go in different places. We probably sell more Omnis because people are using them outdoors and they're trying to keep the access points inside. But as far as different applications, a lot of it's around directional. And you have regular patches, which can be for what I call non-high density areas. And then you have your whole high density, and we use some things, and it could be another series I could talk about just in itself, is dual polarity, where you're messing around with, a vertical polarized element and a horizontal all in the same antenna package. It helps you get around co-channel interference, helps with these very dense areas. So depending on the application, and that's the first thing that you would get asked by anybody calling in is, what's a radio, what's the application? From that, we can say, okay, it's not a high dense area. So we really just need to focus on really good coverage. Like, again, I use an example of a warehouse, probably not a real dense environment as far as people being crammed together, but you really have to have some really focused coverage because you got these long, hallways of racks of product. So you may use a regular patch, but you have to use a specialty patch because of the fact that it's, can have to be in that, focused environment. Whereas let's say we're doing a soccer stadium where we have 100,000 people crammed together and everybody wanting to send video of the soccer game to their family, you're going to have some pretty high dense, type coverage, and you have to use a lot of access points and very focused coverage. So here's just an example of a warehouse. A warehouse is probably one of our biggest verticals. In fact, this last year, this particular product right here, and I want to keep it more technical versus product folks, but this antenna was probably our number 2 selling antenna in the world because it's really, really good for manufacturing and distribution centers because it can go really high in the air, 20 plus meters and beam down very focused coverage of aisles. And it's really good for these big distribution centers and even manufacturing centers that are warehousing a bunch of products. This one right here, which is the one I showed you, this probably our number 1 selling antenna. Not even probably, it is. And it's used a lot for retail, outdoor areas where you're going to put your access point maybe inside and you want to beam into a parking lot or beam into just a big open area. We've seen people put them in freezers a lot in retail because they want to, again, keep the access point outside, put the antenna inside because it can handle that tough elements a lot better than the access point. I mean, I know you can put them in enclosures and we sell the enclosures, but my opinion is if you can figure out a way to keep the access point in a good air-conditioned environment and the antenna in the harsh environment, it's always better. This is an outdoor case for COVID. When I talked earlier about some of this remote power, this one they had power on the roof. But in this situation, you could have easily put up a solar panel. They were beaming into the parking lot so that kids could come in and work in the parking lot for an hour. This was kind of at the beginning of the pandemic, and now they're trying to figure out how to do it where it's more permanent. But it was a quick way to do it where people could come in and get high-speed internet to be able to do their classwork when, again, we were trying to keep everybody home. Large public venues, one of our biggest verticals, whether it's, again, football/soccer stadiums to hockey to basketball to, auditoriums at universities, really having that focused coverage. External antennas are critical. The dual polarity, another thing we always like to take into account. How can we get, a lot less co-channel interference with some of this cool antenna technology? So that's another big one. And then education. We've used education a lot. Again, this particular picture is from one of the installations where they wanted to have an access point per classroom. We're like, okay, we'll put a very focused antenna that gives you a nice little small coverage, turn the power down in the access point. And it worked out very well. It's very little bleed from classroom to classroom, and talk about good coverage. I mean, everybody's happy with the network, that's for sure. And with that, that was really all I wanted to cover. I wanted to allow Matt to have a little bit of time to go over his demo. So I'm going to turn off my camera now so you don't have to look at me anymore. And Matt, I'm going to turn it over to you.
Yeah, sure. So you say a little bit of time.
Yeah, and Sam, if you can make Matt the presenter, I guess.
I will do, yeah. 1 second. Okay, Matt, you should have control. Just while that's getting set up, we've had a question from Paul about what other safety precautions should you take when mounting externally, such as lightning arresters and things like that. I don't know if you want to quickly talk about that, Carter.
What was the question again? I want to make sure I'm crystal clear.
What other safety precautions if you're mounting, things externally, such as lightning arresters? How do you protect them from the elements?
Well, I mean, so for first of all, that's a great question. If you're installing an antenna outdoors, you have the risk of a lightning strike hitting it, no question. And if it hits that antenna, the antenna's got copper elements, and it's going to hit the copper coax. It's going to go straight into your access point and potentially hit your network, and you could cause a lot of network damage. There's been situations where buildings have burned down. So proper lightning protection is important. And I'll look at it two ways when I'm looking at lightning protection. One is you have what we call surge the little gas discharge protection that goes between the antenna, the lightning arrestor between the antenna and the access point. And they're little small, very inexpensive devices. And what they kind of do is protect the antenna between the antenna and the access point for like what we call near strikes. A lot of times, I mean, I'm sure you guys get lightning storms just like we do. You'll have like little feeders and you'll have static electricity, and a lot of times it'll kind of get hit by static, and it can actually destroy the antenna and sometimes hurt the access point. These little lightning protection devices are like almost like they have little fuses inside of them. Very inexpensive way to protect that part of the network. But in addition to that, we're big believers in providing what's called Ethernet surge protection. And what that is that goes between the access point and your main network, your switch, your router, or whatever. And what that is a small device. It's about, I don't know, it's very small, about I'd say probably 10 centimeters or something long. And what it does is it actually, the RJ45 port plugs between both sides of it. And what it's for is if you take a direct strike. And that happens if your antenna gets hit. Now you're going to destroy the antenna, and your access point's going to get destroyed if you take a direct strike. But what it'll do is it'll stop it right there at that Ethernet surge protection device. That way it doesn't get back to your main network. The key is you got to make sure, one, these things are grounded properly. They have to be at a true ground. Any kind of lightning protection, whatever you do, has to be grounded properly. So I guess from a safety, make sure you ground them and make sure you have them. It's one of those that normally when we tell people, hey, what are you doing for lightning protection? They're like, what? I say, you make dang sure you have lightning protection. They'll always say, oh yeah, that's a good point. If you did nothing, I mean, if you have to choose between what I call the little lightning arrestor that's between the antenna and the access point and the Ethernet, I would choose the Ethernet. If you do both, you got even more protection, but you need to have, I think to me, the Ethernet surge protection is a no-brainer. You have to have it. It really protects the network for that, if you take that big strike.
Great, thanks, Carter. Okay, sorry about that, Matt. Over to you.
Cool. Yeah, no worries. So my demo's been built up to be this amazing, long, in-depth demo, but it's really probably the quickest Ekahau demo in the world. So all I'm going to show you guys is just a quick way to find Celtex antennas when you're doing your designs. So here we've got Ekahau, just general design, warehouse. We can go into edit the access points. As you can see here, the antenna section, you can do a quick search. You can have a search by, if you know which antenna that you're looking for, search for Celtex, or alternatively, you can put in the part code and it'll bring up the options there as well. So yeah, easy way to find the antennas. all of the antenna patterns are loaded into Ekahau. They're also loaded into IB Wave, air magnets, so you can do designs today using our antennas. So yeah, if you need any help with understanding what the best antenna pattern is, then give us a shout and we can help with that as well. And yeah, that was the demo.
Thank you, Matt. Very short and sweet. That's how we like it.
That's just like me.
Yeah, and on that note, our product is in the other, tools. We love Echo. They're a great product, but just if you're using somebody else's tool for site surveys modeling, we're probably in there as well, just as a side note.
Yeah, and obviously if they're not, then just let us know and we can work with the Wi-Fi design software vendor to make sure that it is added. Okay, Carter,
Perfect.
did you have any final slides to finish up on before we do
only
questions?
just my contact information and probably more Matt's, because Matt, and then obviously we have a mix of people on the audience. I would start with your Open Reality contact and get with them. If there's somebody from Open Reality, get with Matt. So just to make sure everybody's talking to everybody, but just making sure you have our contact. But that would, again, I wanted to keep it around 30, 35 minutes, which is exactly where we're at, to allow for any kind of questions or more questions if anybody has it. Obviously, if something pops up, after this and you're like, oh man, I wish I'd asked that, just you guys can email Sam or email your Open Reality person. They can get it to us, or again, I don't mind, Sam, if you send out our contact information as well, whatever works for y'all.
Yep, fantastic. It's also worth noting that we do have a limited supply of antennas for people if you want to test some out. So again, contact Matt in the or one of the Open Reality team, and we'd be happy to discuss your requirements and what you're looking to test.
That is actually a great point. We're big believers. You can't build out a wireless network without at least doing a test on the antenna you're going to install, especially if you're going to buy a bunch of them. We can do the predictive. We can do all the, what do the spec sheets look like, but we're big believers in demos. So we've outfitted Open Reality with some demo gear, and we can do that to help you guys out to test this stuff. So I don't know, Matt, you were kind of looking at the question and answer. Was there anything else that popped up, or are we good on questions?
A couple of other questions, which is worth just discussing. So good question here. Why use our products, our antennas over OEM vendors?
Okay, because of you, Matt, right? They get to work with you.
Yeah,
that would be the number one reason.
What more excuse do you need?
First of all, the OEM guys are buddies of mine. They do a great job, and they have some good antennas. You may find that they have something that works perfect for you, and that's great. Use their stuff. We're really rifle focused, and the reason why the OEMs, like us, like Cisco and Mist and those guys, is because we spend a lot of time looking at, where's their gaps. I'll give you a great example. Our warehouse antenna. We were the first to launch that, and pretty much the primary people selling that all over the place, and that's why we're selling it all over the world. The OEMs we work with today, none of them have that, 13 dBi. It's kind of shaped like a fan antenna to really, really work with these distribution centers that are big, that have long warehouse racks of aisles. They don't have the antenna. So they love the fact they can come to us and say, hey guys, use our radio, but, buy Exceltex antenna. But the OEMs, they make good product too. They're great guys. And, we prefer you use our stuff, but there's nothing wrong with using theirs.
I think one thing that we should highlight as well, that Exceltex antennas are considerably cheaper in costs compared to the OEMs, as well as the complementary RF patterns that
better value, I guess, sometimes. Sure. Yeah. But again, if you want to look at theirs, you should. They're probably a good product. Anything else, Matt? Or?
Yeah. So does antenna orientation matter?
Yes, antenna orientation is critical. And in fact, I always tease that don't really care how you mount the access point. You can put it anywhere. The antenna and how you mount it is critical. Where you mount it, how you mount it. That's why we spend a lot of time. All of our antennas ship with really, really good mounts. Some of our competitors ship antennas with no mounts, and then you have to figure out what mount to use. We're big believers in shipping a really high quality mount with all of our antennas. So that's one thing that's really cool. And because we're trying to make sure, one, the installation's easy, but two, that you put it in the right, not only how it's supposed to be mounted, but in the polarization. By that, I mean, for example, a lot of these antennas are supposed to be vertically polarized. Well, what does that mean? I'll take a directional. Let me turn my camera back on, might be easier. Y'all thought y'all were done seeing my face, sorry. This antenna is designed, as an example, for the energy to come out this way. So how you mount it, and let's say you're trying to cover off the top of a building, a part of a parking lot. Well, you're going to need to orientate it and mount it in a way and position it where it's designed to beam in that way. But this antenna is not designed really by its design to be installed this way. Could it work that way? Sure, it could work that way, but your pattern's not going to be what you're looking at on the spec sheets. And really, it's not how Ekahau is going to put in their tool. They're putting it to be mounted this way. So no question, the way it's mounted, the way it's situated is critical. And also make sure you're pointing the direction you want to go. Don't install it this way if you're trying to point that way. Same with our Omni antennas. We've had people call us before and say, hey, I'm not getting the coverage I want. And they will say, send us a picture. And we found out they mounted it this way. It's really not the way this antenna is designed to be installed. It's designed to be either installed this way or this way, depending on whether you're indoor or outdoor, but it's not designed to be that way. Now, I'll caveat that with Wi-Fi is more of an art than a science sometimes. I've seen people install them this way to make it work. It doesn't mean it couldn't, but that's really not how it's designed. You'd have to actually design it and for the understanding it was going to be this way.
Fantastic. Good answer. Matt, anything else?
That is it for the questions.
Okay. So thanks, Matt, and thanks, Carter, for a really good session. Hopefully that's given everybody a bit more information about why you should use an external antenna and sort of how you can get the most from them. Obviously, we're on hand to answer any more questions. You've got Matt's contact information. I'll make sure that's included on the email which follows up with the recording. And again, as we've said, you've got your Open Reality account managers as well, who'd be more than happy to find the answers.
Yeah, we really appreciate you having us on, and we appreciate the partnership, Sam. And just so you guys know, Matt's located kind of outside of Manchester, so he's pretty close to probably most people on the call. So that's also nice. Just wanted to point that out. He's not in the States. He's with you guys. Anyway, all right. Well, you guys have a great rest of the week. I appreciate your time, and please, any questions, let us know. We're here to help any way we can.
Fantastic. Thanks, everybody, and enjoy the rest of your afternoon.